So welcome to our Go Green webinar. We are very happy to be with you today to talk about our sustainable development strategy, to talk about what we have already done in the past and what we are planning to do in the coming months and years. So today we will present to you our project called Lisi Automotive Goes Green. And for that presentation, I am with Fabien Ruhlmann, our HEC director.
Hello Pauline, hello everyone.
We also have Audrey Gaulin with us. So she is the life cycle analysis engineer at Lisi Automotive.
Hello Pauline, hello everyone.
We also have David Merckx. So he's our research and innovation director.
Hello Pauline, hello everyone.
And for myself, Pauline Lacombe, I'm in charge of marketing and innovation strategy management at Lisi Automotive. So we have planned a 90 minutes slot today for our presentation. So we'll have the global presentation of our project, and after we will have a question and answer session. So do not hesitate to ask your questions during the presentation. So you can use the comments area that is provided by Teams or the Q&A session, the Q&A area also provided by Teams. And we will answer to all of your questions at the end of the presentation. So our presentation today will be divided in 5 parts. First, we will talk about our strategy at Lisi Automotive and give some context. After, we will present our Go Green project and the different commitments that we have. We have different pillars in the Go Green project, so we will present some of them during that presentation. The first one is the global range of products that reduce the carbon footprint. Then we have the second pillar, which is about researching new technologies that reduce our CO2 emissions. And we'll present our third pillar, which is about energy and environmental efficiency of our production sites. And at the end, we will conclude. First, a quick introduction. So you all know that we talk a lot about climate changes, greenhouse gas emissions, global warming, and so on. So this is not new. This is already well known by everybody. And when we talk about the temperature that we have on the planet, we can see on the first graph that it increased a lot. So we have the different figures on the graph. Between 1850 and 2020, the figures have been measured. And you can see that it increased a lot, it increased very quickly, and it is very real. Before 1850, it was more stable, so the data has been reconstructed. They have not been measured before, but you can see that it has been stable before. And they have made different tests to see what are the causes of this increase. And if we do not consider the human factor, we will never achieve the same figures than what has been measured. So that means that the human impact is really true, is real, and already exists and has impacted a lot the global warming. So we have some consequences of the global warming, so I will not go into the details of all of that. You all know that it is very impactful. And to reduce this global warming, we need to get very close to carbon neutrality. So this is not an option. We have to get very close to that. And if we have a look to the carbon budget that we have, so that means the carbon that we have the right to emit. On the first line, this is what has already been emitted by all the factors during the different years. And on the bottom, what we can still continue to emit if we want to limit the global warming by 1.5 or 2 degrees. So if we compare the different lines, we can see that if we want to limit the global warming to 2 degrees, we can still emit less than the half that has already been emitted by the human factor. So that means that we need to act now. And this is true for us as people, as individuals, but this is also true for the companies. And this is the reason why our purpose at Lisi is now to shape and share sustainable links. And we have launched one 3P approach that is at the heart of our strategy, which is the people, planet, and the profits. At Lisi Automotive, we produce fasteners and we produce safety mechanical components. And our mission now is to be a sustainable supplier for that range of products for the vehicles of tomorrow. And knowing that, having this different mission in mind, we have launched the new project called Lisi Automotive Goes Green that Fabien will present to you just now.
Thank you, Pauline. So Lisi Automotive Goes Green is the environmental and decarbonization strategy of Lisi Automotive division. This project and this strategy has been launched in mid of 2021, and Green is Go Green is the acronym of the 5 pillars of this strategy. The first pillar is to have a global range of products that reduce carbon footprint and support also our clients in the decarbonization of their purchase. The second pillar is research. Researching new technologies that will help Lisi Automotive to reduce its carbon footprint. The third pillar is the first E of green, is the energy and environmental efficiency of our production sites. The fourth pillar is all actions linked to purchasing and procurement to become eco-friendly, to have eco-friendly action on purchasing. And last pillar is neutral carbon footprint, is the way that we will monitor this project. We'll calculate the GHG balance of the division and to follow all actions. On the right side, you can see the first slide that has summarized this strategy. This slide has been presented in 2021. And now I will show you the new slide that resumes our Go Green roadmap. There's no big changes, we still have the 5 pillars of actions, but we have just adapted, updated and added new action to this strategy. We have added some action to link to the calculation of the CO2 footprint of our product, and to do that we have purchased a software called Gabi, and now we are able to calculate precisely the CO2 footprint of our products. Also, we want to increase the share of recycled material in our products, and we have now some new actions in our Go Green strategy to increase this share of recycled material. We want also to deploy at least one photovoltaic project per year, and we have also added some actions linked to water, as we don't want to be dependent to water in for sites that are in water-stressed areas. We have also some action to test steel that have a low CO2 footprint. And for the last pillar, the pillar for monitoring, we want to maintain the minimum score of B for the CDP assessment. Finally, we have also modified the targets of Lisi Automotive. We want to be aligned with Lisi Group objectives and targets, and they are to reduce the CO2 emissions by 30% by 2030 on Scope 1, Scope 2 and 3A, and we want also to increase the share of renewable energy in order to achieve 20% by 2030. We have also calculated precisely the CO2 footprint of Lisi Automotive division, and that represents 311,000 tons of CO2 emitted in 2022. We have emitted 15,000 tons of CO2 that represent only 5% by on the Scope 1, and that is mainly the combustion of natural gas, but also the emission of cooling gases and the combustions of fuels in our company cars. For scope 2, which is the indirect emissions linked to energy, we have emitted more than 19,000 tons of CO2, but that represents only 6.2%, and that is mainly our electricity consumption. And for the last scope, 3A, we have a total emission of 276,000 tons of CO2, and that is 88%. This scope 3 represents all our consumption of raw material, steel, plastic, but also our consumption of lubricants, chemicals, our investments in new machines, and all transportation, logistic, and the treatment of waste. This CO2 footprint calculation, so this balance of our CO2 emissions will be much more accurate in the coming years, as we have now purchased a software called Trace, and with this software we will be able to calculate precisely the CO2 footprint of each factory, but also to calculate the impact of each action to achieve our objective, which is reduced by 30% our CO2 emissions in 2030. Now I will give the hand to Audrey, and she will explain you what are our actions for the first pillar of Go Green.
Thank you, Fabien. So you're at the beginning of the road here with the first pillar, and I'll go a little deeper into what is product carbon footprint. So when you talk about carbon footprint, there is it's the total of the greenhouse gases emitted that can be caused by an individual, an event, or an organization. Basically, you can do it on everything, but we are doing it on the product right now. And all of this is expressed into carbon equivalent. So you can see there is other gases that are taken into account and then that you convert into carbon. So Fabien introduced you the carbon footprint, the greenhouse gases of Lisi, and I'll talk a little bit more about what is related to our product. You can find it into the request of PCF or an LCA. So for that, we'll go into the life cycle assessment of our product, going through the resources to all the steps of the life of our product until the end of life. But what we do here is that we take into account the resources and to the gate of our plants, so it's cradle to gate, in order to not double count the impact when we give the carbon footprint of our products to our customers. So how are we calculating it? First, we make an inventory of our plant. First, by searching what material we have, the references, and the carbon footprint of each of them. Then going through the energy used by the different processes, and also the consumable used by these processes. So you have, for example, oils, but we take the tooling as well, and maybe if you have some cleaning devices, basically we take everything. And for these machines, obviously you have the power supply, but you also take into account the non-comfort rate of parts and generating a lot of waste. So not only the scraps, but also the consumable wastes. So after we take the subcontractors' carbon footprint as well, and we finish with the packaging carbon footprint. When we have all of this information, we make a model for the process, and this is 1 kilogram of part going through one process. We make a ratio, and you have all of the inputs and outputs that I listed previously that goes into this small box. And this box, we are trying to match the information to the database. So we have, for example, into our software, lubricant data, and we know that we have an oil from whatever brand you want, and we match it. We know, okay, it's done in, I don't know, in France, so we'll match it to the lubricant data from France if we didn't have the information coming directly from our supplier. If we have it, we directly take it into account. So when we have all of this, we create the process flow. So from material preparation to cold forging, heat treatment, and finally sorting and packaging. And when all of this is done, we just have to launch the calculation and interpret it into our software. So let's take an example of a part. So I'll take a guide pin. For this, what we need is the raw material reference, the steps of processes, and finally the mass at steps. We put all these data into Gabi, which is our software, and with these data and the pre-filled processes that we have into Gabi, we are able to make the calculation. So you can see here an example of a flowchart, and we'll dive a little bit more into it with a demo of it. So first, the raw material, you can see here that we can choose where it's coming from. So we have some from our plant and other. Here in the cold forging, for example, you have all of the inputs you can have: electricity, gas, heat, lubricant, filters, and for all of them you have the transportation taken into account. Also transportation to end of life and the different end of life of all of our consumables. Now I want to show you something into the manufacturing. For this plant, you have two types of manufacturing machining machines, and you can choose between the two. It had quite an impact for some plant. And finally, you can go through all of the process. Here you have a component that we might buy and have the info from our supplier. And finally, the plant info that are the same for all of our products. Let's go through the calculation now. And here you have the results. So you have the climate change on this, and you see that our main contributor is the steel, followed by the zinc plating. Okay, so when we've seen all of these results, we try to arrange them and to make it a more readable graph. So you can see here the previous result, and then you see the raw material, obviously, and that is the main impact. So what we want to do is try to improve this point. So our journey with this, first is to make the process request from our main customers, and that everything that is onto contract. And for that, in the meantime, we are mapping each of our plants in order to make a database that we will be able to use to calculate carbon footprint. Finally, we'll try to work with the eco-design on our innovations and our internal development. It leads us to this planning for this year. So you can see we have done already 3 plants. We have 2 plants ingoing and 3 more until the end of the year. Meaning, in terms of product, what we are able to give a carbon footprint for is for the safety mechanical components, basically most of them, everything that is not injectors we can do from different plants, not all of them. For the threaded fasteners, we'll have all the screws available, and for the nut, we'll do it the next year. Finally, for the clip solutions, most of it will also be available this year. We'll have a few that will not as well. But you can see at the end of the year, we'll have a lot of possibility to calculate the carbon footprint of our product. So finally, how will we communicate with our customers? So I'll respond to any requests regarding CO2 of our products, the green energy, and the recycled content of a material, as well as respond to any RFQ CO2 requests. But our aim is that in in the coming months, we'll be able to have a simple interface that can be implemented directly into costing. So you can give the carbon footprint at each new RFQ. So for now, what we'll communicate is this template to give you all the information you might need. So separating the carbon footprint into raw material and what is basically the main impact for our products most of the time, and then the manufacturing. Now I will hand over to Pauline.
Yes, so thank you, Audrey. So we have seen that it's important for us when we talk about products to calculate the carbon footprint of our parts. But it is also important for us to develop our localization strategy to be able to reduce the carbon footprint of our parts. The idea is to be very close to our customers, to be ready to reduce our transports, so the carbon emissions that we do because of the transport, to be able to reduce that, because we are very close to our customers. So we are present in 3 global areas. So we are present in the NAFTA area, in the Euromed area, and in the China area. And the idea would be to continue to develop this localization strategy in the coming years to be very close to our customers to reduce the transport of our parts. So we have finished the first pillar of our presentation. So do not hesitate to ask your questions in the comments area of Teams. And now we will switch to the second pillar of our Go Green project. So David, your time.
Thank you, Pauline. So, as you have already understood, our main focus regarding materials is concerning the use of green steels, but also to work on the processes in order to reduce as much as possible the associated CO2 footprint. If we take the example of heat treatments, you can show on the screen that we try to replace the actual nitrogen that is used in the furnaces by hydrogen. This is done to have a better efficiency regarding the process, but you can see on the graph the direct effect on the CO2 footprint, and we can reduce it drastically. But to go a step further, we have also the project to produce the hydrogen, directly in-house in our Grand Villard plant. And you can see if we do that, we can continue to decrease the CO2 footprint. And at the end of the day, for this heat treatment process that is used on the wire to optimize the mechanical properties before cold forging, we will be able to reduce it by at least 50%. Another way to decrease the carbon footprint associated to our product is to try to produce part without heat treatment on the wire. For this, we need absolutely to control the friction coefficient during the cold forging, and then we need to control perfectly the surface treatment that is applied onto the wire. And it could be applied for simple, non-complex cold forging sequences. I come on this topic just now. This is also in our strategy to substitute the phosphate that is applied actually on our wires. So it is common to apply phosphate. It's the historical process to convert the surface of the steel in order to create a phosphate layer that is able to retain a lubricant during the cold forging process and to reduce the friction coefficient as much as possible. But as you know for sure, this is very far from being green. It uses acids, it makes muds during the process. We are using a 3-acid also to produce the phosphate itself. And it needs a very large amount of water. To give you a rough example, it needs about 250 liters per ton of wire for which we apply the surface treatment. So for sure, we are working hardly to replace all the chemical attacks by mechanical processes, such as sandblasting of the wire or the parts. In addition, we need to replace the phosphate, and it's an ongoing R&D project, and we can, for example, apply a polymer layer onto the surface of the wire to control the surface treatment and reduce the friction coefficient. In parallel, we have to use products that are also compatible with the polymer, and especially with the cold forging oil. If we've got now a look to this graph, we can see that we can already drastically reduce the CO2 footprint associated to the surface treatment. Innovation is key for Lisi Automotive, and it is today nonsense to provide innovative products or processes without thinking about the associated CO2 footprint. We have to think about that as soon as possible into the process, and to do so, we decided to introduce new KPIs to detect as soon as possible if the CO2 footprint is okay or not. For sure, regarding innovation, lightweighting is one of our main innovation axes. Why? Because we can provide innovation, product or processes with a low CO2 footprint, and in addition, lightweighting will also contribute to reduce the CO2 footprint of vehicles. So we've got a kind of double effect on this topic. And regarding our latest innovation, we replace metal by plastic, we work on innovative welding studs, which are light, low CO2 footprint, and we developed also Lisi Micromac AP process. It's a new assembly process based on laser texturing and in-situ additive manufacturing, and I would like just to make a small focus on the process regarding two possible applications. But to understand how we work, first we have to model the process and identify the most impacted steps. We are working with an European mix, so we have to be as close as possible to the reality, and you need to consider the mix corresponding to your own country for sure. For this process, actually at the R&D stage, so quite a big equipment, the CO2 footprint is about 170 grams per assembly point, because the system is quite big and we are actually in R&D mode. And we would like to challenge this process to existing processes and find ways of improvement. If I take the example of structural application, we have already identified ways to decrease the CO2 footprint. The first one is to downsize the equipment, for sure, to be as close as possible to the serial production. So you can see that you can decrease the CO2 footprint by nearly half. And the second and very strong lever is to use recycled material. And when I am talking about material, I am talking about the aluminum powder that is used for this process, and for sure about the nitrogen used also into this process. Regarding electrical application, we can use this process to make optimize electrical connection between electrical cells, here cylindrical. We can also see that the CO2 footprint, the initial one, about 34 grams per assembly point, can be further optimized. And once again, the main levers are using recycled materials on the powder and on the gas. This is it for my part, and I will give the floor to Fabien again.
Thank you, David. So now we will speak about the energy efficiency of our sites. And you can see that represents the third pillar of our Lisi Automotive Goes Green roadmap. So now all Lisi Automotive sites have now an energy saving action plan, and that has been deployed mainly last year in September 2022, as we have faced before winter 2022 these energy crisis due to the Russian and Ukrainian war. Everybody has felt the increase of electricity and natural gas prices. And for Lisi Automotive sites in Europe, we have fixed an ambitious target, which is to reduce by 10% the energy consumption in 2023 compared to 2021, and also 10 more percent in 2024. And all these energy saving action plan are linked to the reduction of heating temperature, limited the heat loss, but also to modernize our equipment and facilities, such like by the implementation of LED lighting, new compressors, electric injection machine, also to propose a renewable energy by the implementation of photovoltaic projects, and also to have a better regulation and control of our facilities. At least we want also to produce our industrial gases, such like hydrogen and nitrogen. The results are quite good. In May 2023, we have seen that we have not so far away from our target. We have reduced by 9% our energy saving compared to 2021, and that represents a global saving of 15,000 megawatt hours of electricity, natural gas, and LPG. And in terms of CO2 emission, that represents a saving of 2,700 tons of CO2. For Fuenlabrada, we have started there a photovoltaic project. So Fuenlabrada is close to Madrid in Spain, and we have installed on the roof of our industrial building photovoltaic panels. We have covered an area of 4,000 square meters for a total power of 843 kilowatt peak, and that represents an investment of more than 600,000 euros. We have a potential of electricity production of more than 1,000 megawatt hour per year, and since April we are producing our first green megawatt hours. Since April we can estimate our CO2 saving on 24 tons CO2. Here you can see some pictures of the project, the boxes that have contained all the photovoltaic panels, the subcontractors that working on the roof in order to install the fastening system in order to fix these photovoltaic panels. We used also a crane in order to install all this material, and you can see different pictures of this project. We have covered almost all the roof of our industrial site in Spain. We have also launched a similar project in Germany, in Mellrichstadt, in Bavaria. Here we have installed the photovoltaic panels on a green field close to nearby the factory. That represents an area of 3,500 square meters of photovoltaic panels for a total power of 749 kilowatt peak. Also an investment of more than 600,000 euros. And here we have a potential of electricity production of more than 700 megawatt hours a year. This project will be commissioned this week, and the potential CO2 saving is more than 170 tons of CO2 per year. Also, you can see here some pictures of this project. You can see here the subcontractor that is installing all the frame, the structure necessary to fix the photovoltaic panels. Pictures of the wiring, that's huge. For this kind of project, we used a lot of electric wires to connect all the inverters to our transformator. And here a short video that shows all the sites, all the photovoltaic sites. We have many other ideas to deploy renewable energies on our sites. We have a target to deploy a minimum of 1 photovoltaic project per year, and currently we have quotation in progress for our sites in Monterrey, Mexico, for our sites of Grand-Villard, Delle, Puiseux, Mélisée in France, and also one project in quotation for Heidelberg in Germany. Also at Lisi Group level, we want to install hydroelectric turbine on the river of Grand-Villard, and this turbine will produce green electricity for the headquarters, but also for Grand-Villard plant. I told you that we have also some project to produce our industrial gas on site in Grand-Villard. That is reality. We have purchased an electrolyzer, and in September 2023 we will commission this electrolyzer in order to produce our hydrogen up to 100 cubic meter per hour, and that represents the full need, the full demand of our heat treatment installation in Grand-Villard. This project will help us also to make a CO2 saving up to 830 tons per year. In the same idea, we have also a project to produce our nitrogen on site. We have a quotation in progress in Delle and Grand-Villard to install a nitrogen filter on our compressor. We want to separate nitrogen from the air on this site and use it on our heat treatment installation. And here we will also be able to make CO2 savings by stopping the delivery of liquid nitrogen by truck trailer. Here you have a short video about our project of the electrolyzer in Grand-Villard.
Bonjour, je suis Fabien Ruhlmann, directeur HSE de Lisi Automotive, et aujourd'hui nous sommes à Grand-Villard, site préparation matière, où nous utilisons de l'hydrogène qui est stocké dans ces racks. L'hydrogène est utilisé pour la protection des bobines d'acier lors du traitement thermique. Au début de l'année 2023, nous allons faire l'acquisition d'un nouveau four de traitement thermique Ebner. Et notre besoin en hydrogène va plus que doubler. Il va passer de 300 000 m3 d'hydrogène par an à 700 000 m3. Mais cet hydrogène a deux problèmes environnementaux. Le premier, c'est de l'hydrogène gris, c'est-à-dire fortement émetteur de CO2. Cet hydrogène a été fabriqué à partir de gaz naturel et il émet 12 kg de CO2 pour 1 kg d'hydrogène. Le second problème, c'est le transport. Pour acheminer cet hydrogène, nous allons avoir une rotation d'un camion par jour qui aura parcouru 200 km. Pour pallier à ces deux problèmes environnementaux, nous avons eu l'idée de faire l'acquisition d'un électrolyseur. C'est-à-dire que nous allons fabriquer de l'hydrogène vert à partir de l'eau et de l'électricité. Ce procédé est 5 fois moins émetteur de CO2 que l'hydrogène gris. Et puis, nous allons fabriquer cet hydrogène directement sur le site de Grand-Villard. C'est-à-dire que nous allons supprimer tous les transports d'hydrogène et ne plus émettre de CO2 sur les routes. Nous avons calculé qu'avec ce projet, nous allons réduire nos émissions de gaz à effet de serre de 830 tonnes de CO2 par an. De plus, ce projet s'inscrit pleinement dans le projet Lisi Automotive Goes Green et la région Bourgogne-Franche-Comté va nous aider à financer ce projet.
We have many other energy saving actions deployed on our Lisi Automotive sites. For example, we repaired our natural gas heating boilers, and in order to have a better regulation of the heat and the energy used to heat up our buildings. We have also reduced last winter, the heating temperature of our buildings. We have also organized the weekend shutdown of our facilities and machinery in order to make a saving when we produce less. especially on the filtering system. These filtering systems are consuming a lot of energy, but also they are evacuating the heat of the building. So during the weekend, when we are not producing or producing less, we reduce the ventilation of these filtering systems. We want also to modernize our sites, and during the last months we have purchased several new compressors that have also a better regulation, and we have also controlled much more frequently the leakage of compressed air. We have purchased for that ultrasound detector that is used on all our European sites, and we have also reduced the compressed air on the right needs of our equipment. Also in Grand Villard, we have purchased a new chiller equipped with a free cooling device, so that means we are now able to use the cold of winter time in order to reduce to cool down the water used on our processes. On our BGCS production sites, so the sites that are producing clips in plastics, we replace the hydraulic injection machines by new electric injection machines, and this replacement is ongoing and will continue also in the coming years. And we have many other actions done on all these sites. Also, some few words about the other Go Green projects. We work also on water. We have a water saving plan for sites that are implemented in water-stressed area, especially in the east of France, in Del and Grand Villard. We are frequently impacted by droughts in summer, and we have fixed targets to reduce our water consumption to a maximum of 7,000 cubic meters per year. And also in Mexico, on our site of Monterrey, we have installed a water tank in order to give much autonomy to the sites, as Monterrey has been impacted last year by a serious drought. They had no rain during 1 year. Also, we have some actions to install some charging station for electrified car on our parking lot in France, that has started in Del and Grand Villard. They are now equipped with a charging station, and we will continue this summer by other sites and also in the following year, in order to have all our production sites equipped with charging stations for electrified cars. Last word about the two other pillars of our Go Green roadmap. We have some actions on purchasing and procurements. We have contacted our energy supplier during the last years in order to follow up much more precisely our electricity and natural gas consumption. Also, we are working with our supplier on 5 strategic procurements to assess precisely the carbon footprint of their products, that are all suppliers of steel, plastic, heat and surface treatment. Also, the supplier that deliver lubricant and chemicals used on our production sites, and also our supplier linked to logistic activities. And for the next years, we will collect also data on our packaging in order to have a precise information about the material composition of this packaging, and also to get information about the share of recycled material in this packaging. Also, we will challenge all our suppliers on their carbon footprint of their products and services, especially on plastic, as we want to purchase plastic with low carbon footprint and with recycled material. Also, we are studying the purchase of biogas, as natural gas represents almost 50% of our energy consumption. We need to consider the option of biogas, and we want also to test low CO2 emission trucks for local transportation. and that could be electrified truck or a truck powered by hydrogen. Now the last word of this webinar is for Pauline.
Thank you, Fabien. So yes, you have seen the different actions that we have already set up at Lisi Automotive regarding our Lisi Automotive Goes Green project. And to finish that webinar, we also wanted to share with you 2 other actions that we have set up. So the first one is to be sure that everybody in our organization is aware of the good practices that we have in our factories or in our offices, for example, regarding reducing our carbon footprint. So we have set up one newsletter that we share to everybody where we can present examples of good practices to be sure that everybody is aware of what we can do and what can easily be done. The other action that we have set up is to develop the marketing research. So we all know that digital technologies has a strong impact on carbon footprint. If the internet were a country, it will be in fact the 6th most polluting regarding CO2 emissions, just after Germany. So it's huge. The digital technologies have a strong impact on carbon footprint. As an example, at Lisi Automotive, we have chosen to reduce the carbon footprint of our websites. So it's a starting point. We have published a research paper last year, and the idea is to continue to develop this research aspect in terms of marketing and to continue to decrease the impact of our digital technologies in terms of carbon footprint. So we are almost at the end of our webinar. For that, we wanted to share with you one video that summarizes what we have done in the Lisi Automotive Goes Green project. And after that, we will switch to the Q&A session.